So here in our next code sample, we have an inline class with pointers, and I've added little noodles here of complexity, just as a callback to our structure discussion from, well, weeks ago now, so that it'll help refresh your memory here. The reason here on line number 3 that we have include memory is because instead of just using a pointer to our classes, I'm going to use a unique pointer to our classes. Now, in the very same way that we did this with a structure, the reason for doing this is that a unique pointer manages its own reference to an object, so that when that object is no longer being used, it can actually go through and free up the, however much space, so the memory that's being used for that object. Now, again, is that super important when we have 3 objects here in the run that we're going to do? Arguably no. But it is a fantastic way to make sure that your developments use space as wisely as possible, so that when you are done with a reference to an object, the same way that we would be here in very, very short order, that we assure that the actual storage is released for other general use instead. So that aside, the rest of everything here is going to be the same that we saw in our previous example. Here, 7 through 18, we have our class definition. Again, remember, we have private and we have public. So the private members of this class are going to be double width and length, and the public members of this class are going to be the functions associated with it. Here, after, again, the semicolon to resolve the end of our class definition, we are going to have our functions. But remember that we do have to resolve the scope of what those functions relate back to. If we just had set width, that would really reference a function that's not associated with the class. We want set width, set length, get width, etc. to be associated with the rectangle class. So that's why we have right here the separated with the colons, right? That's the scope resolution operator that helps C++ at compile time reference, oh, these belong to rectangle, our class, as opposed to these belong to everything, and will be distributed freely here inside of main. So the big wrinkle here is really just another throwback to structures from chapter 12. When we are creating instances of our objects, these are our dynamically allocated pointers to these objects. So we have a rectangle kitchen, new rectangle. We have unique pointer rectangle bedroom, new rectangle. You get the idea. And again, the way that we would actually reference the member functions of this class would be with our arrow, the slash greater than, like you see right here on line 58. So this is how, when we use the unique pointer like this is how when we use a pointer like we did with structures before, that's how we would reference our classes member functions. So this is otherwise identical to the previous example where we did not use pointers, but this one we did.